Hi, this video is going to go over the answers for the Module 7 quiz. So let's go step by step each of the 10 questions. The first question just asks you to interpret a correlation of positive 0.64. This relationship is positive because you see the positive sign, obviously. And the interpretation of this is as institutional violations increase, which is your independent variable, the number of crimes committed once released also increases. So remember, because it's a positive relationship, these variables are moving in the same direction. Also, this is a very strong relationship. If you go back and you look at the charts that were given to you both in the PowerPoint and in the book, you can see that this meets that threshold of 0.30 in the social sciences. So that is a very strong relationship. The next question, question 2, asks you to actually run a correlation yourself between age and overall work-family conflict. So how we do this is we just go to correlate, bivariate, and I always flip this, make it a little easier for all of us. You're going to correlate age, and you're going to correlate work-family overall. You're going to click OK. And you will see in this window that the correlation is negative 0.359. So that means that there is a negative relationship. So as someone's age increases, overall work-family conflict experienced by the officer decreases. So the relationship moves in, or the variables are moving in opposite directions. You also know this is significant, even though this question doesn't ask it, by these two stars here, or if you look here at the significance level. So that is a true relationship, and that it is a statistically significant relationship. So again, it's negative. The correlation itself is 0.359, and it's a strong relationship because it meets that threshold of 0.30. Question 3 asks you what significance tests allow you to do, or what is their goal. They let you determine how valid that your responses are. So you set a threshold, and if you exceed that threshold, then you can say that your findings are actually valid or actually true at a certain threshold. Again, most of those thresholds are 0.05 or 0.05 or 0.05 or 0.01 or 0.001. Question 4 asks you what types of dependent variables and independent variables that you need for each of the following statistical tests. For chi-square, you need a nominal ordinal independent variable and a nominal ordinal dependent variable. For the t-test, you need a dichotomous or two-category independent variable, and you need a metric, so that's interval or ratio dependent variable. And for the ANOVA, you also need a nominal or ordinal independent variable, but you have more than two categories. And you need a metric, which is an interval or ratio level dependent variable. Question 5 wants you to run a chi-square with supervisor as the dependent variable and education as the independent variable. So let's come here. All we're going to do is come to descriptive statistics, come down to crosstabs. Remember, this is where our chi-square is located. You're going to have in the independent variable is education, and your dependent variable is going to be supervisor, not supervisor scale. In the cells, make sure you click that you want the column. And then in statistics, you want chi-square. Click continue, click OK. And a chi-square table will pop up for you. Again, you can see the crosstabs up here of that variable, those two variables. But here's where we actually see the chi-square. So the chi-square value is 4.037. The significance is 0.544. So this relationship is not statistically significant. We know this because this number right here is substantially greater than the 0.05 threshold that we normally set for the significance levels. So these relationships, they are not, or in this relationship, they are not significantly related to one another. And again, you can get all that information from this table. Question 6 asks you when it's appropriate to do a t-test for dependent samples. Remember, dependent samples mean that you are comparing a pre and a post test of the same group of people. So an example when you were doing this, or an example that you could be, is examine or pretend that we have a group of people who are depressed and we're looking at a new depression medication. So we could give them a depression scale right at the beginning, get their mean score on that depression scale, then give them a drug that hopefully deals with depression, and then give them a post-test and get the mean of the post-test of that score. And so that would be a paired sample or a dependent t-test because we're looking at a pre-test and a post-test of the exact same individuals. Question 7 wants you to determine the mean years in law enforcement for both patrol officers and non-patrol officers. So we can go in here, go to compare means, click on this. The dependent variable is years law enforcement. So scroll down here. Oops. And the independent variable is patrol versus non-patrol. Click here. Click OK. And if you scroll down, you can see the means here. So the mean year of law enforcement for patrol officers are 11.07 right here, and the mean year in law enforcement for non-patrol officers are 23.64. Question 8 then logically asks you to run a t-test for independent samples to see if these two means are statistically significant from one another or statistically different from one another. So again, how you do this is you go into compare means, t-test for independent samples. Again, I always do this, it just makes it easier. Your test variable is years law enforcement. Your grouping variable or independent variable is patrol and non-patrol. I told you just to define group 1 as 1, group 2 is 2. Click continue, click OK. And you'll come down here and you'll look at this table. Oops, sorry about that. You'll look at this table right here, and if you scroll over, the t-test is, or the t-value is negative 9.649, and the significance is 0.000. Since that significance is less than the 0.05 or 0.01 or 0.001 that you could even set, we would say that these means are statistically different. So the difference between the years law enforcement for patrol officers is statistically different than or significantly different than the mean years law enforcement for non-patrol officers. Question 9, what is the main difference between a t-test and ANOVA? The main difference is the independent variable. So you have the same type of dependent variable, a metric or an interval or ratio level dependent variable, but the independent variable is different. With a t-test, you are required to have a 2-category independent variable. With an ANOVA, you can have more than 2 categories. So logically, question 10 asks you to run an ANOVA between shift. So you have first, second, and third shifts. So you have more than 2 categories as your independent variable, and the danger scale, or how much danger that the officers feel that they face on a daily basis on the job. So to run an ANOVA, you come here to the general linear model, go to univariate. Okay. The dependent variable in this case is the danger scale, and your independent variable is shift, and you put that in the fixed factors. Click OK, and what you'll see that the 3 shifts here, you really don't have to look at that box very often, but you can come here and look at the test between subjects effects, and you will get a an F value, sorry, not chi-square, oops, an F value of 2.705, and the significant is 0.071. So there is not a significant relationship between shift and how much danger someone perceives, because this 0.071 exceeds the 0.05. That is it for this quiz. Hopefully you guys did well. If not, you have any questions, shoot me an email or give me a phone call. And only one more left after this. Have a good day. Bye-bye.